Huang, Sex, Circuits, and Deep House.
All right. Hey, thanks for the... Okay, sure.
Oh, it's just very sorry to interrupt. You know, we have a lot of people still standing in the back, and I see a lot of empty chairs here. So for the talk, you need to sit down. Because, so please everyone, so you want to sit at some chairs here. If somebody has a chair next to you, please raise your hand. So our friend from the back can come and sit down. Yeah, and by the way, we have a group of students from Dubai here. They are from secondary school, but just to assure you, this talk is nothing inappropriate, so it's okay, so the student can participate, so totally fine.
All right, we're going to wing it all. So, so thanks. I was asked to give a talk, I guess, here, and I actually gave this talk a little bit earlier, and one of the organizers saw it and says, "Hey, this sounds like an interesting thing to talk about since the theme is about Internet of Things." And I was at an event called Burning Man last year, and I brought a little sort of open source Internet of Things device that enabled people to have sex. And we'll go into what that means a little more in the course of the presentation. How many people here have heard of Burning Man? Okay, about maybe a third of the people have heard of it. So I have a few slides to sort of introduce people to this concept because it's actually a little foreign if you haven't heard of it and why we do this sort of thing. So Burning Man, about 330 days of the year, it looks like this. It's a desert. And basically you bring everything in, you have to bring everything out, and you leave no trace. And for 7 days of the year, this desert builds a city the size of Bukatima. About 70,000 people arrive in about a period of 2 to 3 weeks, and they build an entire city. So about this many people land in Singapore every 1.5 days. So it's a huge infrastructure task to build essentially a city overnight in the middle of the desert. And if you're going to build your own city, you're going to build it exactly how you want to do it. So a lot of people come and they build a lot of artwork. So you can see they actually build huge temples on the top left here made of wood that actually gets burned at the end of the event, and then all the ashes are swept away, so there's no trace of the burning actually happening in the desert. There's a lot of like different amazing cars and exhibits. Huge sculptures of people the size, sort of the size of small skyscrapers being built out in the desert. There's a lot of really loud music. On the top left there is a speaker system that is a bus, essentially, coated with speakers on one side. It has 85,000 watts of power, and it's actually like a number that's more reasonable to represent horsepower. It's 110 horsepower of sound coming out of the bus. So that's about the amount of power in a small sedan, and that's all being used to sort of move the air around it. You can feel it from a kilometer away. And a bunch of other different buses like this that drive around the desert, and they have these DJ sets that, everything's free there, so you can go and just walk up to the bus and listen to music and so forth. And then of course there's a lot of hippies who come along and enjoy this, doing a lot of very hippie things. So all these pictures that you've seen of people coming in strange costumes and doing strange things and whatever stuff in the desert is also entirely true about the event. But one of my favorite things about Burning Man is that there's like no internet and no mobile phones, right? So you don't have this thing where you have people sitting together, like a group of friends, just texting themselves when they're actually like right in front of each other. And you also don't have the situation where you're completely attention deficit. You actually get a sense of immediacy. You actually get to sit there and you have to interact with people together. So this is one of the quote-unquote art installations. It's a couch someone just puts out in the middle of the desert, and you can sit there with your friends and talk with them. And a lot of people do building and so forth. So when you don't have the internet to distract you, you can build a city basically in 2 weeks. Whereas if we all had the internet, we would just sit there and watch pictures of cats for 2 weeks. One important thing about being in a desert is that at nighttime, this is what it looks like 350 days a year. It's dark. There's no lights. There's no street lights. There's no infrastructure. So what happens is that people bring lights, lots and lots and lots of lights. So I don't know if people here have had a chance to see the sort of light exhibition down by the Marina Bay area. It's really quite pretty, and actually as people were putting it together, I had this sort of eerie sense that I was, again, at Burning Man, people started to build this weird city of lights in the middle of nowhere. And they have some pretty stunning exhibitions going on down there, and it gives you a sense of what it's like to be there. Except this, Burning Man, it's like several square kilometers coated with lights. There's a kind of really awesome light setup where someone had buried in the desert a set of discs that all communicate with each other, and you can sort of do a Dance Dance Revolution in front of like one of these moving buses and dance on the discs. They all change color. And just lots and lots of lights. Everything's lit, because part of the problem is that if you don't have personal lighting, you can get run over by a car. People have actually been injured or even killed because they're too dark at night and then people are moving around. And so the lighting is actually kind of a mandatory thing to have. So when I go there, I actually camp with a group of people. It's called the Institute. They're a bunch of people who primarily knew each other through university. It's 3 different groups together in one. It's called the Phage, the Laxomat, and the False Prophet. It's sort of this interesting cross-section of society where the Phage is a bunch of nerds. That's where I camp with. And then there's a bunch of guys who went off and became like artists, and they formed False Prophet, which is that logo on the lower left. And then a bunch of guys who went to finance and did like high-volume trading stuff, and they call themselves the Laxomats. And they have this sort of post-apocalyptic aristocracy theme about them, and so they like actually bring their own bar into the desert and set it up and serve drinks and that sort of stuff. But we're the nerds, so we actually like to build infrastructure. We actually build like electricity and the running water and the showers and stuff in the camp, and then the bankers bring along the booze. But one of the things about being out there is that everyone has to help. I mean, like, it's not like you can just show up and expect things to happen in this particular camp. This is it's hard to read from back there because of the dimness of the screen and so forth. But this is like the sign-up sheet for different tasks. Like, people have to manage the jobs, do treasury, gatekeeping, webmastering, making sure that everything stays on schedule and time. And me, coming from Singapore, it's actually very hard for me to get involved. I can't come a month ahead of time and help cook meals or prep things. And so I built a bunch. What I do for the camp is I actually build lighting for them at night. And so for the past few years, these are some examples of the things I've built. Like on the left-hand side here is an example of a badge I made that looks like our logo, which is very pretty but very spiky. It actually got caught in a bunch of stuff, so that was actually sort of a half-good idea. And then I built a much simpler one here, which is just a small badge you could like put on your backpack or wherever it is to light yourself, some personal lighting. And I also tried building another one previously that had some sort of connectivity that would allow people to identify where people are. But at the end of the day, the problem is that all these previous iterations, the depth of engagement was pretty shallow. I gave people a button they can press, and then another person would flash me on the side of the room just to know if they're around. But it wasn't a really deep sense of interaction. And the other problem is that like 3 or 4 years ago, sort of blinky things were sort of new and kind of cool, but now everyone's got blinky. So like when I had to go this past year, I wanted to invent something that was different and not already out there before. So when I set out to design this badge, I had a bunch of goals, a bunch of practical, kind of boring goals, like reasonably priced, a robust mounting solution, integral batteries and LEDs, and a good radio range. But the most important piece, I wanted to focus on interaction-focused design, right? I wanted the badges to be a social icebreaker between people and not just a vanity element. And I also wanted to sort of be inclusive. I want everyone in the village that we're living together with to start interacting. But very importantly, I had to walk a fine line to make sure this didn't turn into an SMS or chat platform, right? Because I remember that first slide, the thing I like about Burning Man is we don't sit there looking at our phones the entire time. I don't want people to sit around alone and just dick around with these things for hours and playing on their own. And so I decided to model the interaction around sex. Sex is the answer to at least 2 problems that I had. One is, how do you configure your lights, right? So you need to, if you have a light pattern, you want to make sure you say, I want to be blue or red or green or flash in a particular way. How do you configure your lights? So instead of giving people a set of like sliders and menus to go through, I want people to actually have to find other people with light patterns they like, and then interact with them and have sex with them to have their light patterns. And so the question is, like, what is end up being the minimum viable product for sex? this is the design of the badge that ended up happening. It has like here the light array, which you can see. It has a cap touch surface integral to the device. It has an OLED here for the menuing interface. And you can see the antenna here for a 900 megahertz radio that was built into the device to allow people to interact. And this is just an example of what some of the lighting patterns look like at the end of the day and what the OLED is doing. So in an idle state, the OLED is actually doing an FFT of the sound around it, so you can see the music pulsing by. And then you can also sort of see that there's a set of different lights. I'll talk about these more, but they have different characteristics, different spectrums, different hue, different patterns that you can go ahead and interact with people to try and breed the light pattern that you want. So the device itself is based upon a 40 megahertz Cortex M0 Plus, sort of 1980s level computer technology. Had 120K of flash and 16K of RAM, so it's not like a Raspberry Pi, super powerful. But we were able to fit in there a multi-threaded real-time operating system called ChibOS. It's an open source project. Had 6 concurrent threads running with the LED effects being bit bang in the background and its own thread. So it had a pretty beefy system. We were able to run a network stack and so forth inside of it. And when it comes to the subject of sex is not just a gimmick to try to like shock value people into it. It's actually modeled like on the biological principles of sexual reproduction. Of course, when I say sex, a lot of people think about sexual reproduction, sort of the process of mating. That is not sex. Sex, if you type into Wikipedia, shows this picture here. Sexual reproduction is the exchange of genetic information between people, not the act of having sex. And so we ended up defining a genome for the blinky patterns. So we have I call it the blinkome. It was a diploid genome, like the human, so you have a mother's and a father's pair, and you would have a chromosome, for example, for like the cyclic dimming, the pattern of cyclic dimming, or the hue of the light. And we also made sure we used a color space called HSV, not RGB. I don't know if people are too familiar with these things, but it turns out that monitors are in RGB, and so programmers tend to do the reasonable thing, which is like wham some values in the RGB value and show them on the screen. And if you look at a lot of LED displays, you see a lot of very saturated, jarring colors in them. It's because the RGB space isn't a natural thing that's matched to the way that your eye sees light. And so if you want to build a user interface that looks good and you're a programmer and you don't really have a graphic designer, a hint is to use HSV. Basically all the colors come out right. You can put random numbers in HSV and they actually look a little more like gentle as opposed to RGB. So one of the tricks we used was use HSV to make the mutations look more pleasant as opposed to jarring. This is what the blinkome actually looked like, and you can see there's a little structure we had defined which would have like different bytes to define the period and the rate and the saturation and other different types of aspects of the genome. And then there's a question of how do you actually express the characteristics. So if you guys took biology, you might remember these charts where they had like Mendel and his pea experiment, where they had like peas that were small and big or wrinkly or whatever it was, and they would have these charts. And so we're a composite of 2 sets of genes, one from the mother, one from the father, and how those genes get expressed depends upon expression function. For example, black hair is dominant. You may have a gene for light hair, but the gene for black hair will win. That's a function of how the proteins are expressed as a result of the gene. On the other hand, like height is not one of those things where you have 2 people and you just keep on breeding taller and taller people. You tend towards the median of height. You don't get infinitely tall people by breeding really tall people together. And so you have to sort of pick an expression function. So for example, here we had to choose an expression function for the saturation. How saturated would the lights become at the end of the day? And so we wanted actually lights to become typically saturated. We want saturation to be dominant. So we did a saturating add of saturation sort of gene and created that. But if we instead took the average, you would find that the lights would not be saturated, tend towards a median of sort of a kind of a grayish color. And so we were able to, through expression functions, create a different set of variants that would come out in the population. For example, I created a little hotspot, this little bright light that would roll around the badge, and it was engineered to be in 5% of the population, in a random population. I put it in there, didn't tell anyone about it, to see if people would just breed with it because it was different. And it turns out that by the end of the event, a lot of people had found that little bright light and started breeding with people who had the bright light to make that much more common in the population, which sort of like went towards one of my theories that people, go for slightly unique traits just because of a vanity thing as opposed to being necessarily a fitness thing. We made like a left-handed or right-handed dominance, and we did a fast or slow spinning kind of expressions. And so you can now see a little more sense out of these lights. So you can see, for example, this one here has a dimming property where it has a single cycle of dimming. This one here is 2 cycles of dimming. And this one here is an extremely rapid hue cycling type of genetic expression. And so if you were in a situation where you saw someone's lights that you particularly like, you would go up to them and you would have to ask them to have sex. And I made it very, very important that both sides had to consent, because you don't just have sex with somebody without asking first. You had to go say, will you have sex with me? And they had to say, yes, I'll have sex with you. And then you go ahead, and then a sperm packet would be emitted over their air to the other device. It would be received. The eggs are generated on demand, so there's no menstruation or cycle needed. A mutation function is applied, in which case the data is converted to a gray code to allow the mutations to make more sense, because if you just do mutations on like binary data, you can get extreme variations if you happen to flip a high bit accidentally. And we bring them back. And then also the mutation rate can be increased by shaking the badge vigorously during sex. So there's an accelerometer on the inside. If you wanted to go ahead and have a greater rate of mutation, you could shake it up. And there's a little bar that tell you like the mutation rate. And one of the things I found is that people would just shake it because they thought it was funny to shake their badge during sex. And people would do this thing where they would mount a carabiner on it to mount it to their bag, and they would shake it with a carabiner flapping around. And we end up with a lot of broken screens because they keep on smacking into their screens. Anyways, at the end of the day, that would create a new genome which would be saved and would replace the current genome that's being displayed. And then finally, you can go about having casual sex with your friends. And this is actually like the lines of C code that it described the process of having sex. When I wrote that, I was like very sort of pleased to sort of be like, I just wrote sex in C. That's pretty cool. When we decided to go ahead and build the hardware, of course, we had to fund it. So I went to a platform called Crowd Supply, which I've used several times before, to go ahead and do a private funding campaign within my camp. At the end of the day, we were able to build these. They were assembled in China. We raised about $6,000. You can kind of see at the end of the day what all the different expenses are. If you actually use the Chinese ecosystem, which is a completely different talk that I can give, it turns out you can build these things for fairly cheap without losing a lot of money. And then finally, one thing I had to consider in the process of doing this, again, like I said, we're in the middle of the desert, so there's no Challenger, no Symbol Square, no Element 14, there's nothing, right? So when you bring the badges out, you have to bring a full repair kit. I brought a soldering iron, assisted optics, diagnostic tools. I had spare parts, so when I talked about the people who were breaking the screens, I replaced like 10 screens in the middle of the desert, in the middle of like a dust storm, trying to get these people ready for the nighttime, because if their badges are broken at night, they're dark, and it's actually a very dangerous situation. I had to handle firmware updates for these devices, 100 of them, in the middle of the desert. So I built a little device here, which you can see, you just slot the device in and press a button. I call it the drunk hippie test. Like someone had to be able to update their own firmware while they're drunk without having to ask me to do it for them. Otherwise, I'd be just doing tech support the entire time. And you had to bring out chargers for 100 units, micro USB cords for 100 units, and so on and so forth. So a lot of the sort of life cycle management also had to be thought through in the process of doing this. And finally, that will be it for the presentation. Thanks.
All right, a round of applause. So essentially, it's blinky lights, badges. I mean, that mutates and becomes new blinky lights.